All right, as you can see, today's topic will be dealing with surface area of both pyramids and cones. And it won't necessarily be in that order. I wrote this out and then went and opened up IXL, and I decided to pull that topic up under geometry. And you can see that the very first one that we're going to look at is going to be a cone, actually. And what I really like about IXL, if you decide that my voice is too annoying, or if you decide to really branch out and try some things on your own, is at the top here, they do have a Learn with an Example option, which is pretty nice. So if you go to Learn with an Example, it'll give you a problem similar to what you're looking at, or yeah, it's similar. It's not the same one. Okay, good. And here they're saying, here's how you find the surface area of a cone. It gives you your key idea. And this is actually what it does if you miss the problem too. So if this is the problem we were trying and we'd gotten it wrong, it would tell us what we'd given, it would give us our key idea, and then it would give us the solution. It actually works out how to find it. So here they say that the surface area of a cone, and different people write this differently for the record, but for a cone, it's the area of the base, that's the big B, we've seen that before, and then LA is something called the lateral area. And that's referring to this actual cone part of it. Like if you're thinking about an ice cream cone, the ice cream cone piece, the cone itself is the lateral area. The area of the base is referring to the circular region, which wouldn't actually be there on an ice cream cone. That would be the open spot. But if we're looking at this as a solid cone, they say take the area of the base, which we know pi r squared. That's the area of a circle. That's not too big of a deal. And the lateral area is pi r times s, where s is actually your slant height. That's this 9 here. It's the diagonal line that kind of lies on the surface of the cone itself. Now our hope is for a generic cone that, we're not dealing with anything weird, crooked or anything. We can just go straight up, not have to worry about any oddities happening. And we'll go in and notice that this problem they already worked through. They were given the diameter, so they cut it in half to find the radius. They were given the slant height. And they're using, now again, IXL, when they use pi, they always use 3.14. So don't use the pi buttons on your calculators for these problems, although I prefer that for my own work. So here they found the area of the base. They did pi times 3 squared. They found the lateral area, pi times your radius times your slant height, and got this. And so your surface area is just the combination of all your areas. So they take this 84.78, this 28.26, they just add them together. That's the area of the base plus the lateral area to get the surface area. And then there's your total there. Now they rounded to 2 decimal places here. Let's see what they want us to do. They do nearest hundredth. So let's actually try this one out. What I'm going to do for my first example, excuse me, is in my personal notes here, I'm just going to write down the r equals 3. They gave us the radius. And I'm going to write down the s equals 6. That's my slant height. So I'm going to pop over here, and we don't really need this picture anymore, by the way. That's the whole idea. Once you know r and s, you're in good shape. They said that surface area is your area of your base plus whatever your lateral area is, your base being pi r squared, and your lateral area being pi r times s. So in this case, r is 3, like in our examples. This would be 9 times pi. And then this is going to be pi times 3 times 6. And 3 times 6 is 18, so this is 9 pi plus 18 pi. And I like to add them up this way, because then I can just plug them into the calculator one time only. Because 9 and 18 I know to be 27, so this is 27 pi. So for IXL, make a note here, this is IXL, we're going to type this in as 27 times 3.14, and that's going to give us what we're looking for, hopefully. So here we go, let's go ahead and find that value. Clear out some stuff from previously. 27 times 3.14, that's 84.78. So let's see if we did anything incorrectly here. 84.78, and we'll submit that, and you got it. All right, excellent. So this is very similar, very much the same idea. It gives us a radius, it gives us a height, or not a height, but a slant height. And so my suggestion would be that you pause this and just try to recreate that process, and then hit play, skip ahead if you need to, or watch what I do, and kind of work through that. So here we have a height, excuse me, goodness, a slant height of 4 and a radius of 1. So we're going to go through that same process. We have pi r squared plus pi rs Well, r is just 1, so this problem's going to be a little bit lackluster, actually. We're going to have pi, because r squared is just 1. Plus, this is going to be pi times s, because r is just 1. Really, when you have 1s, r is just going to fall out, because they're multiplying, so it doesn't do anything. So we have pi plus 4 pi, which is 5 pi. So we're going to just go in real fast and do 5 times 3.14. And this is telling me 15.7. We're going to hope that this doesn't get upset that I don't put the 0 there. And it says, well done. Perfect. All right. This is kind of funny because the first time I went through and kind of took a look at IXL for this skill, it showed me a whole lot of pyramids and not really many columns. So I'm going to go ahead and skip and just see if it'll give me a pyramid instead. It did. Okay, good. So here we're going to take a look at our pyramid. And we're going to say, well, we got a few things we could try to do here. The assumption is that we're going to be able to work with each of our different sides here, and that we're going to be able to work with the base as well. Now, it looks like my base on this one is an equilateral triangle. So what I mean by that is all 3 of the base sides are 13. So what I want to do is go ahead and think about this as finding the area of the base plus the area of all 3 other sides. And it looks like in this case, all 3 of these sides are going to be the same. So we had the base, which has all lengths of 13, and it gives us a height of 11.3 for the base. So I'm going to put a little 11.3 here. So I want to find the area of the base plus, so let's say area of this part plus the area, actually let's do 3 times the area of the other triangle. So there's 3 of the same ones. These have a height of 16 and a base of 13. So these, the slant height is 16 and the base is 13. So I want the area of this one, which is 1/2 base times height, plus I have 3 copies of the same exact triangle here. So I want 3 times 1/2 base times height. So going through that again, surface area is all about finding the total combined surface of the whole thing. So if I peel apart that whole figure, I have the 3 triangles that make up the slanted sides that actually make up the pyramid portion. And then I have this one triangle here that makes up the base of the whole pyramid. So for this triangular pyramid, I have 1/2 13 times 11.3 to get the area of the base of this thing, plus 3 times this right here. And by the way, if you really think about it, if you're really careful about it, notice that this right here is sort of like the perimeter. 3 times 13 is sort of the perimeter of that bottom, and then it's 1/2 that height there. So you might start to see patterns show up in these things. And the good news is we have our handy dandy calculators to work with. So we're just going to bring this thing up here. Now you can't see the buttons I'm pushing, but you can still see what goes in. So we're just going to do 0.5 times 13 times 11.3 plus 3 times 0.5 times 13 times 16. And that's a lot to type into the calculator. It looks really messy. There's a lot of those little multiplication symbols. So it's always good to just look back at it, make sure you typed it in right. I'm using 0.5 instead of 1/2 just to save keystrokes. So 0.5 times 13 times 11.3, that looks good. Plus, okay, and then we have 3 times 1/2, so 3 times 1/2. Now I'll go ahead and scroll over. It should be times 13 and times 16 at the end there. Good. Now that's telling me 385.45. 385.45. It didn't actually tell me how to round, so we're going to hope it's okay with that. It's good. All right, excellent. Now this one says it's a rectangular pyramid, and that's actually, in my opinion, a misleading statement. It's not wrong, it is true, but I think I would have focused on the fact that it's a square pyramid because the bottom has the same side lengths. So we're going to see the same sort of thing happening again here. With the bottom being a square, we're in really good shape. So I'm pretty happy to see that. Let's go ahead and take a look then hopefully we can kind of follow the same process. We're going to take the area of our square base. So 19 by 19 plus, now there are 4 triangles this time, so be careful. Don't just assume the 3 each time. Because our base has 4 sides, our pyramid's going to have 4 of these slanted sides, these pyramidal sides. That's not a word. Anyway, we've got our 4 sides out here, our 4 faces, and we notice that the slant height is 18. So when I go back over here, I have 4 triangles. So we're going to have 4 times the area of these triangles. Now these triangles, again, we had a height of 18, but they have that same base of 19 here. So it's going to be easy enough. I'll take the area of this one, so that's going to be 19 squared, plus 4 times the area of this one. Now you can simplify some first. You know, half times 18, that's really easy to work with. But this is one of those times where even I go to the calculator because I feel like it's more of a matter of saving time. Because 19 squared is one that I don't know off the top of my head. It wouldn't take me too long to figure out, but it's one of those things where if you're trying to get through a lot of problems very quickly, especially, you want to make sure that you're not wasting your time on little details. So I have my 19 squared, I have my 4 times my 0.5, my 18, and my 19. And using my calculator to save some time, that's 1,045 square inches. Let's just make sure that we're on the right track here. Now we didn't skip anything important. There we go. Super. So here's another one like that. I'll actually say for this one, this will be a good place to pause, try it out. And then real fast, I'll go ahead and find that value myself. In fact, I'll do this one a little bit off screen so that if you're kind of following along, you can take a second to jot this down. And I apologize for the coughing in the video. It's something I just have to deal with right now. So back to this one. Notice the difference here is that our square had an 11 for the side lengths. So instead of 19, I have 11. And then the height was 14 instead of 18. So 14 here instead of 18. So going back over, we'll go ahead and hit enter. I see 429. And my hope is that is exactly what we're going to get. I almost typed the wrong number there, so that's good. All right, so that's the same type of problem. Let's go and jump a level, see if anything crazy jumps out at us. Here's another cone problem. I'm going to go and point out the only thing that's more difficult on this one is remembering not to accidentally use the 16. You want to make sure to cut that in half and end up with your R value of 8 instead. So be careful about that. Let's jump a level again. If we see nothing too interesting here, then maybe we'll just move on. This is the same as earlier, just with bigger numbers. This one is the same kind of stuff with decimals. That was interesting. All right, let's see if the challenge zone is actually challenging. Oh, okay, so maybe we'll work backwards just a little bit. And then we'll call it a quits after one like this. This would be a good way to kind of see. This is the culmination of being able to work backwards, being able to take something and say, okay, I know how to work in one direction with this. Can I work in the opposite direction? So this gives me a surface area of 139.8556 square meters. It gives me a radius of 3.4, and it tells me that S is what I want to find. I almost said S is something that we have. I was looking at S and this 3.14. So saying use 3.14 for our pi. And so we want to go back here and say, this is our question. It's given us this. Maybe I should say colon. We saw earlier that our surface area is pi r squared plus pi r s. Well, we're trying to figure out the value of S. So we have this situation here. We're just going to plug in the values that we know. Our surface area is this. R is 3.4. So again, R is 3.4. So we have our S over here. Now, I go ahead and I'll apologize if you hear kids in the background. My kids are a little loud sometimes, and they're starting their day. I'm going to subtract this first term here from both sides. Once I've subtracted this term, I need to get S by itself, so I want to divide by the thing I'm multiplying here, that 3.4 pi. So I'm going to divide that by 3.4 pi. So just walking back through that, we had a piece that was being added, so I subtracted it from both sides. And then I had a piece being multiplied by my s, so I divided it from both sides of my equation. The only difference here, and how I'm going to put this into the calculator, is that IXL wants me to be careful with the pi's and make sure to replace them with 3.14. And I know my pi's aren't drawn very well, by the way, so if anybody's worried about that, don't be. Now I'm going to go ahead and make sure I'm careful. I'm going to actually use the alpha y equals to set up my fraction bar here, just so that this doesn't get too messy. 139.8556 minus 3.14 instead of pi times 3.4 squared. That's everything that it wants on the top. And then I need 3.4 times 3.14. And that's going to give me what I want on the bottom. So here, it looks like S is 9.7. I got a fairly clean number for that. I'm not sure what just happened there. Excel was not wanting to open. And there we go.